Hello everyone. Chapter 1A is titled Equations, Inequalities, and Mathematical Modeling. In this first part of Chapter 1, we'll look at graphing linear functions, finding x and y intercepts, we'll look at writing an equation from a word problem, and we'll end with graphing inequalities. The first page of your notes packet just has our learning targets listed for you. When you feel confident in these learning targets, we will be ready for our assessment. Let's go ahead and kick things off with Lesson 1.1, Graphs of Equations. We're going to look specifically at linear equations in this lesson. We're also going to look at identifying x and y intercepts. When asked to determine solution points, a solution point of an equation is an ordered pair that when substituted in for x and y in an equation just makes the equation a true statement. The example down below, determine if the point lies on the graph of y equals the square root of x plus 4. If we're given an ordered pair, you're simply going to substitute your values in for x and y. Notice it's y equals, therefore I'm going to write 2 equals. And then our big square root symbol. X, we have 0 plus 4. We just need to decide if this is a true or false statement. Well, 0 plus 4 is 4. The square root of 4 is 2. That is a true statement. Therefore, yes, 0, 2 does lie on that line. Let's try 5, 3. Again, same idea. Substitute in your x value and your y value. The y value is 3. If we set that equal to 5 plus 4, on the inside of that square root, 5 plus 4 is 9. And guess what? The square root of 9 is 3. We have another true statement, which means this point is also on the line. When asked to determine if a point is on the graph of that line or that function, all you need to do is substitute these values in. This is the kind of work I would be looking for credit. When asked to graph linear equations or functions, we have two methods for graphing. We can use the slope-intercept method when we have y equals mx plus b, and there's an alternative when it's not in that form, ax plus by equals c, when you have standard or general form. And down below, we have an example of each. To graph an equation that's in slope-intercept form, you always want to make sure that the number in front of x is simplified, and that is our slope. If the slope is positive 2/3, from left to right, it looks like you're going to be walking up a hill. The number that's written after, whether it's positive or negative, represents the y-intercept, or where you start on the y-axis to plot your points. If it's -4 on the y-axis, so the y-axis is the vertical, let's just review that quickly, and the x-axis is the one that goes left and right horizontal. If we start down at -4 on the y-axis, I'm going to put a dot there. From that point, I'll use the slope with the rise over run definition. I'm going to count up 2 units for rise and over 3 units for run. So that's a slope of 2/3. I like to continue that pattern all the way to the right side of my graph, and then I'm going to reverse that set of directions on the other side. So I'm going to start at -4 again and count down 2 and go 3 to the left, making all the points that I'm plotting on this coordinate system collinear. Once you have points that go all the way from edge to edge, go ahead and connect your line and put arrows on each side. Your graph should look something like this when you're done. When your equation isn't in slope-intercept form, there's another method that you can use for graphing. This method is called standard or general form, and it's called that because the x and the y are on the same side. The number or coefficient in front of x is your a value, the number in front of y is the b value, and then c stands for the constant on the other side. Now in this form, we can still determine our slope, we just have to do so a little bit differently. So I'm just going to rewrite that there. The slope formula comes from taking 2 of those 3 coefficients. The formula, by definition, is -a over b. You're going to want to write that down. That's a good formula to remember. So in this example, a is 4 and b is 3. That means the slope is actually -4/3. We'll need that when we graph. The y-intercept is going to again involve two of the three values, and that's just C divided by B. And again, jot that down. That's a good formula to know. If we take 12 divided by 3, our y-intercept is 4. This line, when we graph it, will look like we're walking downhill from left to right. We'll start with our y-intercept of positive 4 on the y-axis. Since the slope is negative 4/3, we're going to count down in one direction, but then to the right in the other. So one's kind of going in a negative direction, and the other one counts in a positive direction. If I count down 4 units and 3 to the right, that puts me right on the x-axis. Continue that pattern again all the way to the bottom edge, and we get pretty close over on that right-hand side. To do the reverse, if I count up 4, that means I have to go 3 to the left. If you look at those 5 dots, it looks like we're going downhill from left to right, so please draw a line to connect them with arrows at the sides, or at the edges. And that's an example of graphing in general or standard form. You can always take this equation and convert it to slope-intercept if you'd like, and you'd get the same values to work with. So really, the choice is yours. We'll end today by looking at intercepts of a graph. So the graphs will already be given to you for this section. Intercepts are simply points that cross either the x or the y axis. An x-intercept, and this is what the ordered pair would look like, crosses on the x-axis, which seems to make sense, I would think. And the y-intercept, given this ordered pair, will cross over the y-axis. Given graphs might have none of these, maybe one of each, maybe two of one or the other. It just depends on what the graph looks like. Recognizing that the x-axis is always that horizontal and the y-axis is the vertical, notice there's only one y-intercept here, and there aren't any x-intercepts at all. In that second graph, if we think of the x-axis, there are 1, 2, 3 different x-intercepts, but then on the y-axis, notice one of those ordered pairs repeats itself. There's one y-intercept. In the next example, there's only one x-intercept on that x-axis, and then 2 along the y-axis over here. And then that last example, there aren't any intercepts at all. On that example up above, or the example set up above, we just stated how many there were. In this part, we're identifying the x and y intercepts of each equation. When you're asked to identify them, we're going to do so with ordered pairs. In the first example, y equals x cubed plus 1. This is called a cubic function. Notice from left to right, it looks like it's kind of increasing with a slope, but then there's kind of that little plateau in the middle. This is not a linear function. This is nonlinear. If we're asked to identify x and y intercepts, let's just do one at a time. Possible x-intercepts on this graph. Along the x-axis, I see only one point where it crosses on the x-axis, at this location right here. And that ordered pair would be -1, 0. All x-intercepts will have a y value of 0. For the y-intercepts, same idea, we just go along the y-axis. Counting up on that y-axis, I see there's only one y-intercept as well right here, and that's at 0, +1. So just one of each. See if you can try the next one. Determine the x-intercepts and y-intercepts. Pause the video and write down what you think they are, and then press play, and we'll see how you did. If you notice along the x-axis, this quadratic function crosses the x-axis at 2 locations. Therefore, there are 2 x-intercepts at -5, 0 and 0, 0. The y-intercept has a matching coordinate. Right at 0, 0, it's true for both the x and the y-axis. So for this example, there are 2 x-intercepts and only one y-intercept. And that's it for lesson 1.1. I'll give you your CYU assignment tomorrow in class. For now, please just show your notes to the sub, and then the rest of the hour you have study hall. Thanks, everybody.